I hope you all are good and doing well for the preparation of your upcoming exam, uh, May June 2025. Okay, guys, here I'm going to discuss about the recently done paper in your mock exam March 2025, paper 4. Here, the first question states a ring is threaded on a fixed horizontal bar. Ring is attached to one end of the light inextensible string, which is used to pull the ring along the bar at a constant speed of 0.5 meter per second. The string makes a constant angle of 24 degree with the bar, and the tension in the string is 6 Newton. See the diagram. I have resolved the forces 6 Newton. That is is mentioned as the what inextensible string which is used to make a bar constant speed. Yes, the tension in the string is 6 Newton. So I had resolved the tension into its components. One along horizontal is 6 cos 24 and 6 sine 24 vertical components. Right, I have resolved this, and now we have to find the work done by the tension in the string. We know the work done. Work done is what? Force times displacement, F times T. And we also know that the driven force, what is the F is a driven force that is along the horizontal component of the tension. So here I can say the ring is driven on the horizontal bar with the force F, that is 6 cos of 24 degree, right? And you are given along with it constant speed is u and v are the same, that is 0.5 meter per second, that is given. And work done by the tension in the string, period of 8 seconds. Time is 0.8 second, you are given it. And we are behind the distance, how much apart, because if we know the d, then we can find the work done. So we know that driven force minus resistive force is equal to net force, because the ring is moving along the horizontal bar. Okay, and for this driven force, if you multiply the driven force each side term with the d displacement, so F times d minus RF times d is equal to, here Na comes to be what, because constant, the body is moving constant velocity speed, so it means acceleration is here, acceleration is 0 meter per second, because u and v are constant, and acceleration rate of change of velocity or speed that's in particular direction, so here it will be 0. So I can say this is the work done by driven minus work done by resistive is equal to 0. So work done by driven can be written as work done by resistive. We had tried this formula, and for this formula I need to find d. What will be the d? D will be what? S, and S, S, we have to find S is equal to ut plus half at square, as a is 0, so S becomes ut, and that is 0.5 times t is what? 0.8. You will multiply this 0.8, no sorry, it's 8. Here it is 8, not 0.8. So you can do this, 8 for the 40, so S will be 4 meter. So S is 4 meter. Therefore, so work done by driven, this, yes, work done by driven force is equal to any FD, F driven yani 6 cos 24 degree times d. We have calculated 4, so we can use a calculator to get this. It's going to 6 5 is 24 cos of 24. To change the calculator mode in degree, we will see the work done by driven force goes to be 21.9 joule of work is said to be done. I hope it's clear because it's a so easy question. Just we need to find d to change the word, to find the word done. Now question number 2. A car of mass 1500 kg is towing a trailer of mass m kg along a straight horizontal road. Okay, like this. It's a car, and this is going to tow a trailer right. That's towing a trailer and car are connected by tow bar, which is horizontal, light and rigid. Okay, this is a tow bar with tension. Long tow bar is same here and here. T1 and T2 will be same. Okay, T1 equal to T2 because that is rigid. There is a resistance force F Newton on the car. Okay, here first one, it was 1500 kg was the mass of a car, and m kg the mass of our trailer. And the resistive force, as the car is applying force here, this driven force, and here it will be resistive force. How much is that? F Newton. Okay, on the car, and resistance of force of 200 Newton on the trailer. It means trailers is going towards left, so resistance will be opposite of it. 200 Newton towards here. The driving force of the car's engine is, this means this is driving force, that is 3200 Newton. The acceleration of the car is, any acceleration of the AC is what? 1.25 meter per second square, and it will be the same as for the trailer, because with which acceleration the car will move, the trailer will move accordingly, because that is rigid tow bar that is going to fix with the both car and the trailer. So acceleration for the both cases will remain same, and the tension in the tow bar is, okay, here it is given to be tow bar tension in the tow bar is 300 Newton. Find the value of m and the value of the force F. So here we need to find these two things. It's a 5 marks question, interesting question. So guys, here we need to do one thing. We can apply the conditions of the rule that driven force, the car is going towards left, minus resistive force is equal to net force. We will apply this rule simply here. So first we'll talk about the car. Here I can say, for car, you know, the driven force is what? 3200, and resistive force is 1 F Newton, and tension as well minus 300 Newton, because these two forces are against the driven force of the car. And the net force is MA. M is 1500 and A is what? 1.25. Now here we have 2900 minus F is equal to 1500 times this 1.25. The calculator 1875. So F will be 2900 minus 1875. The calculator, I got 1025 Newton. This is the force, right? So F is what? 1025 Newton force is the resistive force applied on the car. Now similarly, we can go for the trailer now. For trailer, we know the driven force minus resistive force is equal to net force. So here driven force of the trailer is about tension, and that is 300, and the strip force is 200 Newton. Opposite the motion of trailer is equal to net force MA. M and A is 1.25, so 100 is equal to 1.25 times M. So M will be 100 divided by 1.25. So you'll see in the calculator we'll get it 80 kg. That is the mass of the trailer. I hope it is clear. It was easy question, 5 marks question. Okay, now next question is about particle projected vertically, vertical motion of the particle with the speed of, it is given the speed is u meter per second, initial speed, okay, from a point on a horizontal ground. Okay, suppose this is the horizontal ground and the particle projected upward with a speed of initially u meter per second, and acceleration upward will be equal to g, that will be minus 10 meter per second square. Okay, and after 2 seconds t is equal to, the height of the particle is 24 meter. Okay, it's going up, but after 2 seconds, suppose this height is from here is till ground is 24 meter. So you are given s, that is 24 meter, time is given to be 2 seconds, and a is equal to g, that is minus 10 meter per second because going up, that's why it is negative. And u we have to find, so applying the SWOT equations, the second one, that is s equal to ut plus half gt square. So s will be what, here given 24, I will replace the values. U we have to find t2 plus half times minus 10 times t is 2 square. So 24 is equal to 2u minus 5 for the 20. It will be 44 goes to be 2u. So u will be 44 by 2. So then u will be 22 meter per second. It's a so easy question, 3 marks question. Okay, it's proved. You have to prove this, so it's proved. Now the second part, the height of the particle above the ground is more than h meter from a period of 3.6. For a period of 3.6 seconds, find h. We have to find h now. Now you can suppose the figure, like see the figure. This is the ground. Initially, suppose it is the particles goes up, and this height is h meter above the ground, and height of the particle ground is more than h meter from a period of 3.6 seconds. Okay, so it is more than now. Suppose it comes to be here the maximum height. This supposed to be the maximum, and it takes more than 3.6 for a period of 3.6. Here from here is 3.6. So I can see the height from here till here. It takes time. Time goes and time up, down for the particle, and at maximum v is final velocity will be 0 meter per second. Initially we have already calculated in the part 1, that is 22 meter per second. You can use that. And from here total time of 3.6 second more, so 3.6 divided by 2, because half time it will take to go up, and then from the maximum to come down. So 1.8 second is the time this particle takes to reach at the maximum height, and then come back to this again, this position. Say this is O, this is A, and this is B, right? 1.8 second from A to B, and then B to A, the same time it will take. Okay, so now we have to find, so first we have to find the time taken to reach the maximum height. How much time it will take here? T is what? So first we will calculate time taken to reach at maximum height that we need to find. Say that is t first. We have to calculate it. Initially you are given u is 22 meter per second, and g is going up, so minus 10 meter per second square because it's going up. And at a maximum v is 0 meter per second. So first equation of SWAT, v is equal to u plus at becomes gt is 0, u was 22, g is minus 10, and t we have to calculate. So with the calculator, 10t 22t will be 2.2 second. So this is what 2.2 second time to reach at the maximum height. Now we need to find the time above h. This is total time, right? This is total time to reach from to the maximum height. So time, therefore I can write, therefore time above h, above height h will be 22 minus 2.2. So 2.2 minus 1.8 already we have calculated. We'll get this 0.4 second is the time that above the maximum height. It will be at the maximum height, 0.4 second it will be at the maximum height. So now as we are looking for h, so s or h will be ut plus half gt square. So h will be, u is what given 22, and time is what 0.4 we have calculated. The difference of times plus half minus 10 and 0.4 square. On the calculator we will solve it, and we get 8 meter is the height for a period of 3 second above the ground. So this is the required height. This is the final answer. Okay, next question. An athlete of mass 84 kg is running along a straight road. Okay, the person is running along a straight road. Okay, it's going here. Its mass is 84 kg. Okay, initially the road is horizontal and runs at constant speed. Constant speed means acceleration is 0. Any a is 0 meter per second square, and speed u and v is the same, that is 3 meter per second. And the athlete produces a constant power, so power that is 60 watt. We know that power is equal to what? Work done in unit time, and work done is what? As running, so force times displacement over times, and we know d by t will be v, so f times v. We have derived a formula, p is equal to f times v here. So power is 60, and resistive force we have to find force, and speed is what? 3 you are given. So F will be 60 divided by 3 gives you 20 Newton. This is 20 Newton of force which is required to do this. Okay, now in B part, the athlete then runs up at 150-meter section of a road which is inclined at an angle of 0 degree to the horizontal. Okay, now the athlete is running this one, that is 0.8 degree horizontal, and he is running like this. Okay, he's going towards this direction up. Okay, the distance from here till here is 150 meter. Okay, yes, athlete, and at the start of the section of the road is 3 meter. Speed is start, and you're given is the speed at the start is 3 meter per second, and he now produces a constant driving force of 24 newton. So it means it is applying a driving force of 24 newtons. Mean if instead of this figure, if I draw like this, right? So it means driving force is what here I'm going to apply this one. So driving force, because it's going up, so I can write its driven force is F driven force is 24 newton. You can draw the figure for your understanding. It's important to draw because we need to resolve it in its components, and then we can with the help of those components we can find the solution. And the total resistance force which acts on the athlete along this section is around the constant magnitude is 13. It means the opposite to the motion is 13 newton. This is resistive force. Okay, it's given. Using an energy method to find the speed of the athlete at the end of the 150 meter. Okay, here we need to find total 150 meter end of this. So energy method says that the work done by driven minus work done by resistive is equal to change in kinetic energy, because going to increase in motion with different speeds, and because going up, so plus potential energy. So here we can apply this. Here we know here driven force multiply by this distance will give you the work done by driven force, because distance is 150, and same goes with the resistive force multiplied by d will give you work done, and change in kinetic half m v square minus u square plus mgh. And for h, the height here it is, this is we need to find. So distance is total is 150 meter from here till here it moves 150 meter, and theta is we can use the cot or sine theta is equal to opposite upon hypotenuse. So h will be 150 times sine 0.8. With the help of calculator we can get it. You can find the results that come 2.094 meter. This is the height. So now just apply the rules, values in it. In this rule, driven force is what? 24 times distance covered is 150 minus resistive force was 13 times 150 half m. Now the u square and b square we have to find the speed v square minus u was what? 3. Initially it was given 3 square. M mass was how much the mass was? 84. Yes, it is given here 84 kg and g 10 and height 2.094. Now just calculate it. We'll do the calculation to get the final answer. We can get it. It will be 3600 minus 30 times 15. We get 1950 is equal to half times 84 times, because m is 84, v square minus 9 plus 84 times 10 times 2.094. We get 1758.96. And finally simplification, you can do the algebraic manipulation to see as 3600 minus 1950. We get 1650 is equal to 42 v square minus 42 times 9 is 378 plus 1758. 1758.96. 758.96. Sorry, 1758.96. We get this value. It goes other side, becomes plus 1650. Okay, we get 42 v square is equal to 1650 plus 378 minus 1758.96, and do this on calculator. 1650 plus 378 minus 1758.96, we get v square is, we get this here 269.04 divided by 42, I will get it 6.4057. So square root of the answer will give me the final result, that is 2.53. So v will be square root of 6.40577, that gives me 2.53 meter per second. That is the final answer of mine. I hope it is clear. Okay, here question number 5 says the particle P and Q moves on the line of greatest slope of a smooth inclined plane. Smooth means no resistive force will be there. The P is released from rest. It means initially from rest u is equal to 0 meter per second, and on the line a 2 second later passes through the point A. It means here smooth inclined plane, that makes suppose angle theta degree along the horizontal, and the particle is here initially 0 and it comes to at A. Slide zone release from the rest, so the u is 0. After 2 seconds passes through the point A with the speed of, in here the v will be 3.5 meter per second. Acceleration of the P and the angle of inclination, we have to find the A and theta. Okay, simply we need to know about the dissolving forces of it. If I can resolve this, yes, here it is the contact force, right angle to the inclined, and this is the weight W, and WMG, and here it will be the components. Theta comes here, so W cos theta, W sin theta, and you know W is equal to mg. Okay, fine. Now go with the conditions. U was 0, V was what, 3 meter per second, and T was after 2 seconds, takes 2 seconds. So V is equal to U plus AT. V is 3, U was 0, A we have to find, time is 2. So A will be 3 by 2, that comes to be 1.5. 3 by 2? What was, sorry, 3, it's not 3, it's 3.5, sorry. 3.5, here 3.5. So 3.5, 1.75 meter per second square, that is the acceleration of the particle coming down at point A from O. Okay, now we have to find the angle of inclination of the plane. In theta we have to find, we know for this case, we know the driven force minus, because driving from resistive force is equal to net force. As the surface is smooth, so resistive force is here, resistive force is no 0 Newton. So driven force will be only the weight components, W sine theta, which let the body to go down, minus 0, net force is MA. So W is equal to mg sine theta is equal to MA. A is what we have calculated one in first 1.75. So you can see here cancels. So sine theta will be 1.75 divided by G, and G is 10. So 1.75 divided by 10. So theta will be, we are going to calculate it, sine inverse of 1.75 by 10. So on the calculator, by keeping that in degree mode, your answer will be 10.1 degree. Or if you want to change it in radian, because the condition is not imposed in the question, so that will be fine as well. So that is the answer. I hope it is clear. Let's proceed to the second part of the same question. At the instant P passes through A, that the particle Q is released from rest. It means here is the condition when the particle P comes here, then Q start from O. This is A. Already we have calculated theta as well. We have calculated it. So how long after time t second after Q is released from T, the particle P and Q are 4.9 meter apart. So they are, so that is given that these are how much apart. P and Q are 4.9 meter apart. 4.9 meter apart. Time t second. So it means for Q, for particle Q, which is reached at T, initially again it was rest starting from O, and time to reach at A for the particle Q is t second. Okay, so distance covered by this one is what? SQ will be ut plus half at square. Okay, A already we have calculated in the first part. That was what? 1.75. We will use it now. So SQ will be U was initially 0 times t plus half 1.75 times t square, right? So we can solve this as Q will be on the calculator 0.875 t square. That is distance traveled by the particle Q to come to A. When definitely both particles in motion, so when Q will come to A, yeah, Q will be here, then definitely A will come further somewhere on this inclined plane. The particle P will be somewhere behind, passing through point A. So now we will go for the other particle for P. Particle P, initially it was at rest, U was 0 meter per second. The acceleration was 1.75 meter per second square, and the time, yes, definitely after 2 seconds given mentioned here, line and 2 second later passes through the point A, because from start when it comes from particle P come from O till A, it takes 2 seconds and then pass from O. So time will be here t plus 2 seconds to come pass from the A. Okay, now again we will apply the SP, distance covered by the particle, at what point it will be when Q comes at A, the measure it will be, how much apart it will be. So we can say ut plus half at square, right? SP will be U is initial 0, so whole becomes 0, plus half times 0 point no, what was 1.75, and t is t plus 2 whole square. Okay, so with the calculator we get SP is equal to 0.875 times t plus 2 whole square. This is the distance covered by the particle p when q comes at a, so it will cover this distance. As it is given in the question, given that the two particles are sp and sq are how much distance apart? 4.9 meter. So we'll use the result here. Here is 0, sp is 0.875. Here I'm going to apply it to save the space. Sp minus sq was 4.9 meter. So Sp is 0.875 times t plus 2 whole square minus 0.875 t square is 4.9. So 0.875 is taken as common and taken on other side. So here it will be t square plus 4t plus 4 minus t square is equal to 4.9 divided by 0.875. After taking common, I can solve this. Here this cancels. So 4t plus 4 is equal to, on the calculator we can write it 4.9 divided by 0.875. So I got 5.6. So 4t is equal to 5.6 minus 4. So it will be 4t is equal to 1.6. So t goes to be 0.4 second. This is a time that taken for the when the p and q are 4.9 meter apart. I hope it is clear. Now the final question of the paper, second last question, question number 6. Two particles A and B are masses 0.4 and 2 kg respectively are moving down the same line of the greatest slope of the smooth inclined plane. It means they are coming here down, the particle A and particle B going down with respective masses 0.4, 0.4 kg and 0.2 kg. The particle is inclined at 30 degree to the horizontal. This is the angle formed by them. A is higher up the plane than B is fine. So it means this height is for H2 is for B. In HB is this. So this is for HA. A is higher than B. When the particles collide, the speed of the A and B are this and this. Okay, here I need to redraw the shape like this. Okay, suppose at some place they will collide, A and B. Okay, okay, after collision and when the speed of particle A and B, and finally it will be any A and B will be 3 meter per second and B will be 2 meter per second. In the collision between the particles, the A is reduced. Okay, now it's before it was 3 meter per second, it was 2 meter per second. And in collision particles, the speed of A is reduced to be 2.5 meter per second and B will be, we have to find. So this is simple law of conservation of momentum states ma ua plus mb ub, momentum of the system before collision will be equal to momentum of system after collision. We will apply this rule. So here m is 0.4 times 3 plus 0.2 times what 2 is equal to 0.4 times A is reduced to be 2.5 plus 0.2 times V. So with the calculator we can calculate it, VB. So VB will be 3 meter per second. You can simplify it as by doing simple calculations, you will get the answer. 2 marks question. After the collision, the particle B has moved 1.6 meter down the plane from the point of collision. Okay, this goes to be 1.6 meter down plane. It means here, if I can start here, the new figure. A is coming, say he is here, B will be here. Okay, it hits the B hits the barrier. Suppose here we have a barrier. It hits the barrier and returns back to up the same line of the greater slope. Then it returns back here. B hits the barrier A at 0.4 second after the collision. So after the first collision, it hits the barrier, right? And when it hits the barrier, its speed is reduced to be 90% reduced. So even 10% will be applied on it, which help to drive its motion. The two particles collide again 0.44 second after their previous collision, and they collides on impact. It means now they have the combined masses and combined speed together. So here I need to resolve. We are talking about the particle B, so I will resolve this into its components. It's a contact force, and here is the weight components of B. 30 degree comes here, and we will resolve it. It's W B sine 30 and WB cos 30. Okay, fine. So as B has moved 1.6 meter down the plane, so it means here I can start from here. Given S 1.6 meter down, B moves after collision, and time it takes it 0.4 second to collide. With which speed we don't know. Initially it was coming with 3 meter per second in the part A. From A we get this. Here we have calculated this. So with speed V is equal to U plus AT. V is equal to 3 plus A is what? It was 5 and time was 0.4. So it comes to be 5 meter per second with which it hit. V is 5 meter per second when it hits the ground. Hits the barrier. Right. And A was 5. Here A, did we calculate A before? No. So for A we know, yes, it's driving force minus resistive force is equal to net force. Driving force was what? Here it was W sine theta. W sine theta, and there was no resistive force is equal to MA. So WB was 2 times sine 30 is 1 by 2, and M was again what comes is 2, and A. So 1 by 2 can give you what? It was 0.2. Sorry, mass was 0.2 and A. So we get 1 divided by 0.2. So A will be 5 meter per second square. Here we calculate this one and we use it here. So V comes to be at which when it hits the barrier is 5 meter per second. Right. So now it's given after hitting the barrier, the particle B returns and loses what? The speed is reduced to be new speed will be 10% of, you know, 10 by 100% of the original reduced. From 5 it becomes reduced to be 90%, mean 10% applied. So I can say 10 by 100 times v was 5 is 0.5 meter per second, with which it returns after hitting the barrier. New speed when it returns is 0.5 meter per second. As we have to prove this, show that the speed of b is immediately after it hits the barrier 0. We have proved this, right? Now it said, hence find the speed of the combined particle immediately after second collision between A and B. Okay, after second collision, you know, we can, because collisis now, so we can use the formula here, that is again the conservation momentum, that ma, I will write the other color. Now use ma ua plus mb ub is equal to, as collisis, so masses will be combined, and with a common velocity we will use this, because clearly mentioned this second collision, when in second collision they collide. So here we can apply this second collision, and between A and B combined we have to find. So here we will go for the first, for A, the speed of A after collision becomes u plus at. So t is what is mentioned here. The two particles collide again with, in for time is 0.44 second. So when they after collision again, after second collision, speed of A will be u was, initially it was 2.5 plus A, we have calculated it here 5, and time is 0.44. So the calculator we can get it 4.7 meter per second. Same goes for B. VB will be u plus at. U is plus, it was reduced by, it becomes minus 0.5 because it goes to opposite direction. So 0.5 changes into, now this is VB will change from minus 0.5. Minus indicate that is going in opposite direction. Now VB is what? Minus 0.5 meter per second, because direction is changed. That's why we put minus, plus A is 5 and time 0.44. So it comes to be minus 0.3 meter per second. Right. So now apply this rule here. M is 0.4 times VA will be, this will be, new, that is 4.7 plus M2 is 0.2 times minus 0.3 is equal to sum of their masses 0.4 plus 0.2, and we have to find combined velocity. So in the calculator we can simplify this to get V combined will be 3.03 meter per second. That is the final answer. I hope it is clear. Okay, now guys, the final question is easy. It's taken from the variable exploration. The particle moves in a straight line through the point O, as clear as you are given. Find the time when the particle instantly is at rest. Rest means v0 during the first 6 seconds of its motion. First 6 seconds from here. So the value t we have to calculate its rest. So ds by dt will give us velocity, and that must be 0. 2t minus 3, and it should be 0. So time will be 3 by 2. That's going to be 1.5 second. It's 2 marks question. Second part, at time t6 second, the particle hits the barrier at a point P and rebounds. Same case goes. Find the velocity with which the particle arrives at P and also the velocity with which the particle leaves P. Both, we have to find velocity when it arrives and when it leaves. Two things we have to calculate, the main important points. So we know V is already we have calculated for the first 6 seconds, t 2t minus 3 from here, from the first part we know this. At t is equal to 6 seconds, so velocity when P hits the barrier. So we can find the velocity when particle P hits the barrier. That will be, we arrive, you can say. This is 2 times 6 minus 3, so we get 9 meter per second when it arrives at barrier. Now velocity when the P leaves the barrier. Similarly, velocity when P leaves or rebounds the barrier. V leaves. We have to find this. So for the other case, we know from the other case when t is greater than 6, so S is given to be 24 by t minus t square by 4 plus 25. So ds by dt will be minus 24 by t square minus t by 2. This will be, and here we will replace at t6 at t is equal to 6 second. So v leaves will be, because this goes to be velocity, leaves will be minus 24 by 6 square minus 6 by 2. With the calculator I can get it minus 3.67 meter per second. Negative shows that it's rebounds. Right now we have calculated the two results, that is for when it leaves and when it arrives. So here two things he asked. You are supposed to find velocity when it arrives, that is here, and when it leaves is here. I hope it is clear. Final part of this paper, that is find the total distance traveled by the particle in the first 10 seconds of the motion. Okay, it's a 5 marks question. It needs little calculations. So at t is equal to 0 initial, s will be 2, or you can say at t is equal to 6, s will be 20. You can suppose initially and finally. So at here when t is 0, we can use the first, this one, this displacement is t0 0, and because from 0 it's only 2 meter, and when t is 6, we use the second displacement, that is s is equal to here this one. For t greater than or equal to 6, we get t is equal to s is equal to 20 while getting this answer. So this is total distance. We have to calculate our particle in 10 seconds, first 10 seconds. So t0 till 6 we have calculated. Now at t is equal to, say it is 1.5, because here we have calculated the first part. At t is equal to 1.5, so s will be, that is lying for first. For first we have what? We have t square minus 3t plus 2, t square minus 3t plus 2. So s will be 1.5 square minus 3 into 1.5 plus 2. So it's a distance. We are calculating distance. Distance is absolute value, so we can take this. It will comes minus 0.25 because absolute value is not a vector quantity, scalar quantity, so it will be 0.25 meter. We have calculated this, and we have calculated this, and we have calculated this as well. This is for the second case. S is equal to when it was 24 by t minus t square by 4 plus 25, and this we took S is equal to t square minus 3t plus 2. Now finally, when t is at 10, at t is equal to 10, again it was greater than equal to 6, it was greater than equal to 6, we use again this one. So S will be 24 by 10 minus 10 square by 4 plus 25. We will calculate to get it 2.4 meter. So these distances we have calculated. So total distance we need to find. Total distance will be, first it was 2, then this is 0.25, and then it goes back 0.25, because if this is this, and it will be this, and plus 20 plus we can find this. Okay, for second here, because we have to find the distance from first 10 second, so here we need to calculate this little more. 10 second goes for this case. So for S6 we have calculated, for this case x6 we have calculated it as, it will be what, 20. We have already calculated 20. So this, for this, and S10 we have to calculate 24 by 10 minus 10 square by 4 plus 25. So on the calculator we will get it, this final time will be 2.4. so here, so this is the, the S1 when it was 0, this time, this was t0, t was 1.5, t was 6 for both cases, and here it was t was 10. We have calculated 10 as well, right? 6, sorry, this was what, reverse journey, sorry, 1.5, and here it was 6, and here we have to calculate for 10, 20. So we can say this, the difference of this 20 C10 is 20 minus 2.4. S10 will give me the final result. I will calculate it, which become 40.1 meter. One approach was this, guys. For the second part, we can go over the second approach. You might feel it easy. You can do this by integrating the total distance. For the first case, it was from 0 to 6. From 0 till 6, any total distance, V was what? For it was V, we have calculated here. Yes, we have calculated this one, 2t minus 3. You can do this by with the 2t minus 3 dt to get this result for this case. And for more than 6, we have done this one, V plus from 6 till 10, for 6 till 10, initial 0 till t 1.5. So we need to divide the first time into 0 till 1.5, then 1.5 till 6, and next will be 6 till 10. Okay, 0 till 1.5, and then 1.5 till 6. This is case study for the first time as with speed, and dt plus, and the final will be 6 till 10. For the second case bigger than 6, and that velocity is 24 minus 24 by t square minus t by 2 minus t by 2 dt. Yes, we can do this. So this is the second method, guys. Method 2, either you, if you feel this little hard, it's not hard, simply we just need to divide the time for the, you know, the given range of the time. Then from 0 till 6, first this velocity will take place, and that is part into 1.5, then 1.5 till 6, and next will be from 6 till 10 to get the total distance. So I did it, and either you can go with that or the second method. You can integrate it to get this. The final answer will be 40.1 meters. Choice is yours. You can do it with any method. I hope it is clear. If you find any query in calculation, don't feel any issue, and just text me and I can solve your problems. Okay guys, good luck. Bye bye.